Good morning, everyone, and thank you for joining us for our webinar today. This is Mike Stock. I'm with Evoqua Water Technology, so that's why you can't see those guys talking because I'm the Oz behind the curtain today. I just wanted to start off with the housekeeping stuff. So any questions you guys have as we walk through this, you can type in your questions section on the screen. I also want to call attention to a couple of handouts we have in the handout section that you can find, as well as a video link that showcases our capabilities. So when you have a chance, you can check that out. This webinar is being recorded, and we will provide a link in a few days that you can download the video, and you can also find a link when we send it in a couple of weeks to the entire PowerPoint, which has a very detailed appendix, so you might want to see that. Today, we don't offer a CEU for this, but we can offer a certificate of attendance. So once again, thank you for joining us, and I will now turn it over to Dave and Jeff.
All right, thanks, Mike. Good afternoon, everyone. I'm Dave Scrocky. I'm a BDM with Evoqua Water Technologies, and my specialty is in environmental remediation and construction dewatering. And I'm here with Jeff Salowitz. I'll let you introduce yourself.
Yeah, so Jeff Salowitz. I am actually a founding partner and owner of Coalition Companies. We do owner's representation, and yeah, really glad to be here. Thanks for the welcome, Mike and Dave.
All right, I'll start with the first slide here. Whoops, we're going to pop through. It's going to go fast. If we go that quick. Yeah, Jeff and I are just going to go over what to expect when you run into contaminants on a dewatering site, and then the steps to take to solve the problem. I'm going to kick it off with going over some of the Evoqua capabilities and where we implement water treatment during construction dewatering. And then I'll touch on the permitting phase of these projects. Your water's got to go someplace, and you typically need an application or a permit to get it discharged. And then I'll go over the different treatment processes and some of the equipment that we throw at these sites. And then I'll turn it over to Jeff, and he'll give you kind of a GC's perspective on a site that he and I worked on down in mid-Michigan a couple years ago. And then we'll both go over some case studies and some questions to ask before you break ground. But just to start out, I kind of give you an idea of what Evoqua is all about. And I'm sure you're looking at this slide going, what? Yes, Evoqua does. We play in all these different markets here. If you know, it's just like any process that utilizes water, from raw water from a drinking water well to the discharge from a municipal or industrial wastewater plant. Evoqua's got a treatment system for it. It's a very diversified company. Just for examples, we're a sole source provider for mobile and permanent treatment systems for PFAS and drinking water. We provide water as an ingredient in the beverage manufacturing sector for soda manufacturers, distillers, brewers, my favorite sector. We provide treatment for selenium and different types of constituents in the coal ash generating facilities. And we're probably one of the only providers of resin for the nuclear power plants for their ion exchange units. And we even do vapor treatment thermal oxidizers for the oil and gas companies. So just kind of just a few examples of what Evoqua can do. And Jeff, I'll kind of let you kind of describe what Coalition does.
Yeah, no, thank you for having me. I'll flip over to my slide. If it'll go. But so I'm with Coalition Companies, and I do owner's representation, really with a primary focus on construction. So my background is large construction management. Recognized a need for owners to be represented based on some really big failures that I was seeing within the system. So some quick facts about construction, just to educate you. 70% of projects don't make schedule or budget. Pretty bad failure rate there. 92% of owners say drawings are not sufficient for construction. 37% of materials in the construction industry become waste. 40% of carbon emissions in the US are from buildings, not vehicles. Construction productivity is actually down 19% since 1964. in comparison to 153% increase in productivity from against the non-farm productivity index during the same period. So we've got 170% difference there between how other industries have increased their productivity, and we just keep failing and going down. So where does that leave me? Construction industry is broken. I'm trying to fix it. And in the background, you'll see one of my favorite photos from one of the boats I see during the summer. The name of the big yacht was Change Order, and the little dinghy next to it was his original contract. So a little humor there. Back to you, Dave.
Right. Thanks. All right. To roll here. Okay, today, like I mentioned before, Evoqua does a lot, but today we're going to concentrate on just the treatment during construction dewatering. We'll start from design, modeling, setup, commissioning, and running the system. So first, where do you typically need water treatment in a construction dewatering site? And I think probably most of you will agree that foundation work is probably the #1 thing. I mean, you're opening up a hole, you've got to dewater to get the foundation in, or an elevator shaft. That water's got to go someplace, and it usually has to be treated at least to get the solids out before you dump it someplace. Tunnel construction, we've done a number of jobs on the East and West coasts, not so much in the Midwest, but obviously, you're digging a hole, and again, solids removal before it can be discharged. Hydro demolition is getting big. I don't know if you've seen these high pressure water jet robots that they use on dam spillways and highways and bridges. They do is they use this high pressure water to remove the upper layer of the concrete surface, and before repaving, and it produces this slurry of concrete goo that you need to treat before you can discharge it anywhere. So we get involved in that quite a bit. And then stormwater retention. I mean, a lot of these construction sites remove the vegetation, you get a storm event, your stormwater retention basin's full of dirty, clay-rich water. That needs to be treated before it goes into a river or lake. And then utility corridors and wastewater lift stations, again, probably #2 behind foundation work. Your utility corridor is probably spanning maybe a good city block. You're passing maybe Joe's garage, and you smell gasoline components in the water. When you open up the corridor to dewater, that needs to be treated. And then dredging projects. This is really big in the Great Lakes, especially. I mean, we had a lot of nasty industrial processes back in the day, dumping PCBs and coal tars and nasty stuff into the channels and the rivers there. So when this stuff is dredged up mechanically or hydraulically and put on dewatering pads, that's the kind of water that we treat as well. Next slide here. Okay, I don't want to get all lawyered up here, but I wanted to touch base on the permitting issues that you run into when you start your dewatering. The water has to go someplace, and it only can really go 2 places. You can either dump it in the sanitary sewer, which is your wastewater treatment plant, if you're within the city limits or village or whatever, or you need to go to stormwater discharge, which requires an NPDES permit, because it's going to, when it goes to the storm, it's going directly to the river or lake. And each one of the permits kind of has different, requirements. Sanitary is probably if you're in town, the most likely and best place to go. Access to the sewer is probably pretty good because you can find a spot to dump the water. And because it's a treatment system in itself, the treatment requirements for the contaminants that you may be dealing with that you've found on your site, the requirements for cleanup going to the wastewater treatment plant are probably a little higher, meaning they're a little less stringent because 1, they're a treatment plant to begin with, and 2, they've got so much volume water coming at them, the stuff we're dumping in is going to be polluted. So sometimes it's a little less stringent to get into the sanitary. The permitting wise, you can get a permit with the wastewater treatment plant probably quicker than you can for an NPDES permit, but there's still a lot of paperwork to do, to fill out to get it. The cons are some of the cities that you deal with will charge you by the gallon to dump into the sanitary sewer. And one, because maybe they're overwhelmed, and or two, they just want to make money off you. But you got to watch out for that. And then there are some other stipulations too. You may run into a situation where you'd be on a certain side of town where the sanitary sewer just doesn't have the volume or the capability to handle the flows you need. Your dewatering contractor may tell you, say, yeah, I got to do 900 gallons a minute to keep this hole dry. And the city's telling you that, hey, the most we can take in our sewer is 500. So something you want to think about before you break ground. Going to stormwater, because we're kind of the last line of defense for the discharge to the lake or stream or river, whatever. The criteria for discharge may be a little tighter, so you're gonna have to get it down a little closer. And an MPDS permit, a stormwater discharge permit, just takes forever to get. I mean, in the state of Michigan, it may take you a month or two to get a permit. It's just the filing, the time to get it reviewed is just it's frustrating. But if you don't have any other, if you're out of town and don't have access to sanitary, you've got to go to the stormwater route. One thing I wanted to mention is that we don't actually do the permitting, but we can help you we can provide the information you need for the permit. So we can provide the modeling, we can provide the system design, we can provide process flow diagrams for the application. Usually requires equipment specifications, media specs, all that sort of things. Well, all those things we can help you or your environmental consultant or engineering firm, whoever you've contracted with to file the permit, we can help you process that through. And also want to mention too is that some states have blanket permits for discharge, like the state of Ohio. They have something called a PTI. It's a permit to install. And we've gone through the process of getting pre-approved for different flow rates, 100, 300, 500 GPM for specific sites like underground storage tank removals, foundation work, hydrostatic pipeline testing. We've gone through the process and gotten pre-approved with the EPA. So when these sites come up and say, hey, the design is already approved for different types of contaminants and flow rates. So just something. All right, someone wants you to call us, and the correct answer is as soon as possible. If you run into contamination, the sooner you can get it in our hands and give us the flows you need and the discharge criteria that we need to make, we can start putting the system design together and get this thing mobilized out to your site so you're not losing time and money. So, and we work with the site contractors, dewatering contractors, your environmental or engineering consultants, whoever. We can work with them. So what's a typical process look like? What's the system design look like? And this is this is kind of just a box diagram, but what we get from you is your analytical, your flow, and your discharge criteria. And we've got our application engineering team. They'll model that and give us a list or a treatment train. And these boxes on the right here are the equipment and the steps we need to apply to get it to the discharge criteria that you need. All right. So here on the left, this is your dewatering contractor or yourself. You've got your open excavation, or you've got, say, dewatering points. You've got pumps, and you're pumping it into frac tanks or weir tanks. It's kind of equalization. All right. Our team will tell us what we need to do to treat that water, and our equipment here is on the right. So it starts out with, we may need to adjust the pH. Like I mentioned before, the hydro demolition work, you're creating a concrete kind of sloppy, slurry mess that has a pretty high pH. So just adjusting pH with a little acid to drive it down and knock those solids out may be all you need. If we're dealing with like a dredging project where you've got really high solids, suspended solids, we may have to do a little polymer addition. I mean, it's a matter of adding a coagulant or a flocculant to the water stream, mixing it and settling that out into weir tanks or geotubes or clarifiers, whatever, just to knock those heavy gross solids out so we can continue to treat it. If we don't, then you run the risk of blinding off the rest of your system. Last thing you want to do is throw a bunch of mud in the top of a carbon tank, and if you haven't burned the carbon, you just sealed off the vessel and you can't get water through it. So it's just a process. You slowly get the water down, cleaner to the point where you get the solids out, and then you can treat for the dissolved contaminants that are in there, like the gasoline components or the solvents or metals or whatever, something like that. All right, so how quick is the response? We've done this long enough that we've developed and built skid and mobile units. So what we get from the engineering team as far as a treatment train, we can go out to our yard and just pick and choose the equipment that we need, put it on a flatbed, even pre-plumb it for you, and get it on the road. So it's now at the point where we've created like shelf space for different parts of it, or different pieces of equipment, and they're easily mobilized. Just like, yes, we need bag filters, sand pods, and media, and fill it, plumb it, get it on the road, and set it up. So, and then, as you know, the water at all these sites are different. Not, I don't think there's any one site's the same. You may have, for a tunnel project, maybe you're just dealing with suspended solids, and that's all you need to do is remove those solids. So you'll just throw some polymer at it, or sand pods or bag filters, and you've got clean water you can discharge to the sewer. Other sites, you may have heavy metals, you may have gasoline components, you may have PFAS. We're finding it everywhere now. And each one of those constituents that you throw into the mix requires a different set of treatment in the treatment train. So depending on what you got, we'll set it up for you. We can provide the tankage, and the whole system designed through discharge. And then, we get it mobilized, get it set up, get it commissioned. We also provide the O&M too. You can have us do a turnkey, job where we provide the system operators that run the system 24/7 if you need it. Or if simple job, we can coordinate with you and train your guys to, change bag filters, whatever, and watch the system. So we can be as involved as much as you want us to. And then when it comes to the project completion, we can also provide the media extraction and coordinate, or help you coordinate disposal of the material. Or if say in carbon, if it meets the profile, we can regenerate that material too and not send it to the landfill. All right, at this point, I'm just going to turn it over to Jeff. He's going to go over a particular unique project that he and I worked on in Muskegon, Michigan. Why don't you take it over, bud?
Yeah, thanks, Dave. So I'm going to take over the screen here. We'll move on. So case study number 1, Muskegon, Michigan. This is a convention center, about 40,000 square feet of a facility that we were putting up here. And when we got on site, we ended up with some challenges that actually were not apparent right at the front end. So we had our front end environmental reports, our phase 1 and phase 2 environmental reports. And when the phase 2 came back in, it was really a subnote within the literature that we received back. It's about a 300-page report that we had, and we ended up with PFAS on our site. At the time, there wasn't a ton of legislation. We were still learning about it. It was becoming a bigger deal. We wanted to make sure we were doing the right thing, and so when we found it, it was a little bit later in our development process than we would have liked. So with that, we were right on the lake shore. This looks out on the lake. This actually used to be part of the lake until they dredged and filled in for certain areas of this back in the industrial area. So we had a site that was all fill. It was used to be an old sawmill. It had contamination from a PFAS plume from another site down the road that was drifting into ours. We had a high water table that was just not going to be very conducive to the project. Our flow rate, we're going to have to pump 300 gallons per minute out of here. So, decent flow rate on this site. We would have to keep it continuous. And our PFAS detection was at 41 parts per trillion. What was good about this, we had a quick response. and we had some proven solutions that we could find through our dewatering subcontractor is actually how I came to meet Evoqua. And it actually turned out to be a great relationship. So we were able to reach out to them. They immediately started on design, aligning stuff. They were able to give us some consultation as far as, hey, who do you reach out to for grant funding, et cetera. And so it quickly became this camaraderie team environment that we needed. To get rid of the PFAS, we were definitely trying to get it down to non-detect, which we achieved. And at the end of the project, we had cleaned over 21 million gallons of water and put it back into the system. So a little bit about our project and what made it successful. I'm going to focus on three things. You know, the first thing is the timing, right? Second thing is the scope of the project. And then the final thing was the cost. Everybody always screams budget, and it matters. So we really needed to make sure that we also built out a core team, and there was a lot of moving parts, both from government partners, our environmental consultants, our construction teams, and everybody in between. So let's move into structuring the project with the right team. What you kind of notice here in my diagram is we kind of have what I like to call my Evoqua sandwich. I needed to be at the head with the client, you know, representing their interests, representing what we needed to do for the project. And then at the bottom, we had Evoqua here, who really came alongside me and helped align all of these pieces. So first part, our government partners. We were involved with the city and county. This was a project that they were a stakeholder in. It was a very prominent project for the city themselves. We had to work with the municipal water, right? Could we just dump this in there? Could they treat it themselves? What do we need to do there? And then we needed to work with the state as well as the EPA, or in Michigan, what we call EGLE, same group there. So we quickly established myself as the owner's rep, as a single point of contact for everybody. So we could oversee all of these parties. I could work with the government partners, get all the funding aligned, get all the grants aligned. And then I could also pull in all of our environmental consultants. There was a couple different folks from the environmental side that we needed. We needed testing oversight, right? So this is a check and balance piece to make sure that mistakes don't happen, right? When you're dealing with something, contamination like we had on our site, we wanted to make sure we were doing it right. So we had testing oversight that worked alongside the government partners of EGLE to make sure that our on-site testing team was actually doing things appropriately, and we were capturing all the data that we needed to. And then we also had our construction team. So earthwork subcontractors, our dewatering subcontractors, and really our concrete and foundation subcontractors were the key guys that we had to work with to make sure that we met our schedule and kept everything moving really smoothly throughout this. Throughout all of that, we had a feedback loop, really. So everybody was talking amongst each other, but at the end of the day, to make sure that things went smooth, it would have to come back to myself as the owner's representative to make sure that everybody was finally checking the box and moving forward. It actually created a very smooth process. We'll get into how smooth in a second, but everybody very much understood their roles and the tasks they needed to do. So the schedule. When we started this project, because of some design issues, we were about 3 months behind schedule, right? The owner wanted to make some changes, set us back. So we were already fighting the construction season, right? We get extreme weather up here in Michigan, especially on the lakefront. It's not unheard of to get 6+ feet of snow in this location in a matter of a short time, right? So we're behind schedule. We've got all these grant fundings that we have to apply for. A lot of these take up to 6 months or longer to be able to get. And we have winter conditions because at this point we're going to miss our complete summer portion. We're going to have to be digging through the frost, which adds cost to it. There's extra management time. Pretty much we're going to assume a cost that's going to make this project dead on arrival. So as we go through that funding process, by aligning the right team, having players like Evoqua who came in and designed the system for us, having teams like EGLE, the EPA, who worked really closely with us, we actually went through the entire grant process in just under 3 weeks. So from the time that we applied to the time we received $1 million in funding, it was dream scenario, stars aligned, and it was crazy, right? That does not happen in governments the way that I'd like to see it happen. It was just, it blows me away still. So everybody planned and executed really efficiently. So the team partners, I touched on this briefly. They were key to the success, right? We had to find the right team partners, and by doing it quickly, by getting people on board, we were able to move through that just very purposefully and with a clear direction, right? I am not the authority on PFAS, but I had to be in the know, and I had to have people alongside me to be able to guide the teams, to the right decisions quickly and efficiently. So we defined the scope for each team member, who was responsible for what, made sure that they were able to execute, that they had the tools at their disposal to do it. And that really made it, a very, very quick process on our end. So that brought us to the budget. By understanding our scope, by understanding our schedule, right, we were able to figure out exactly how much it was going to cost us to dewater and treat the water for each day we were on site. It was, rough estimate was 25,000 per day. As we got into it, it was really closer to 23,000 is what we were looking at. And as we found efficiencies, we actually brought that down. But based off of the 25 grand per day to operate the site, we knew we only had 45 days before our funding was going to run out. So we wanted to make sure that we got this project out of the ground as quickly as possible so that we didn't burn through those funding. So how did we end up? End of the day, everybody worked long hours. We had a lot of overtime, but by being efficient, using the overtime appropriately, we only spent 620,000 of the grant funds. Part of that is because our flow rate was so high at 300 gallons per minute, we would have to, part of it was we had to have somebody on site for the entire duration. We couldn't ramp this down and then ramp it back up without flooding the site. So we were going constantly around the clock. Our schedule, because of the delay, only extended 30 days. We were able to recapture that throughout the course of construction by resequencing the rest of the project. So it ended up with a net zero delay for the entire project. And then the design had really minimal changes. We figured out a couple different ways to, have spread footings, a different type of footing that helped us from not having to dig quite as far. So it really ended up being really zero cost to the project outside of the dewatering, treatment, and everything else that we had going on. So I'd love to walk you through the site really quick. As you can see, we took over this municipal road. We had an old oil well that was back here in this corner that we had to deal with. Down here on the front end, we had all sorts of, there was an old sawmill that had been there, and then this was all lakeshore in the past. So the blue here was our original building. This is where we set up our whole dewatering and treatment facility. Right here in red is where we had our dewatering pumps. And then the green is really the core area of where footing and dewatering had to happen. We did have a large EU that we buried this pipe in here that created a large U, and so it sucked up all the water across the site. As we went through this, again, you can kind of see how the building turned out. Over here, this is our laydown yard for Evoqua. This was one of our biggest pits. This is where we had elevators there in the front of the building. And so we had to dig pretty deep to get what we needed for foundations. And so there was a lot of dewatering that happened in this area. As you can see here, here's our frac tanks. So the water would come in along these pipes. We'd fill these up, come over here to the rest of the system. We have, our filtration system here, as well as our kettle tanks that we'd be using. Here's our pump, which would have been right here in the middle of the site. Again, there was, we put piping all through here that kind of came in a giant U around the site and just sucked it up from the key areas. As we went through the foundations, you can begin to see how deep some of this was, right? In some areas, we were down about 30 feet is the deepest hole that we had to dig for our foundations and footings and walls. And again, you get an idea of the complexity and the scope of the project. And then finally, here we were out there pouring, thought these were some fun sites. Obviously, we got the building up. It looked great, you know, big effort from partnerships from all team members. But again, it was great having somebody alongside us who could, you know, walk us through the process, help us understand where to go next, because they'd seen it before. And so that's kind of how the partnership with Evoqua worked out. So I know I was pleased from the ownership side. Dave, any comments?
Yeah.
Back to you.
Yeah, great projects. All right, thanks, Jeff. Yeah, this next one, the second case I just wanted to throw in just because it was unique. It was in Denver, Colorado. It was right on the Platte River. This one's just a little bit different than the Muskegon job in that they sheet piled, they were going to redevelop along the riverfront there. It was an old manufactured gas facility way back when. So some pretty nasty volatiles in there, had metals, they had PNAs, that sort of thing. So they had to dewater and get those soils out of there to get the foundation in. So what they did is they diverted the river. You can see here on the left, and then you had to pump this nasty clay-rich water out of there. And at the same time, the water is mixed with all the contaminants that were in the soil. So we had just a suite of nasty things we had to pull out of there. So this one, if we go back here, see these red tanks here, similar to what Jeff showed you, those green frac tanks. These are weir tanks. And what the dewatering contractor did was he pulled the water out from behind the sheet piling and dumped it in these weir tanks where the gross, solids settled out. And then we on this particular site, we had to do, it was more of a solids issue than dissolved contaminants. So we've got these solids removal trailers. They're called SRS trailers, and they're equipped with polymer injection systems and pH adjustment systems. So we took the water that was pretty clay rich, mixed it with the polymer, and then mixed it and put it back into geotubes, these giant pillows that we put in these dewatering boxes, and that captured the majority of the gross solids. And then once that water filtered through those giant pillows, much cleaner, then we could process it through additional trailers that were behind these with carbon and some ion exchange resins for the metals and the volatiles that were in the water. So just another unique site that we just wanted to kind of share with you. I think now we just want to go over the questions you should ask, prior to opening a hole. I mean, this before you break ground, this is going to keep you on schedule, on budget, and eliminate any of the unknowns. And the first question is, are you going to hit water do you need to dewater or draw down the water table for any type of footings or utilities? And if so, how are you going to do it? In Jeff's case, they used well points, and the water coming at us then is pretty clean. It's just like coming out of your water well at your house. If the screen is sized to the soil type that's in there, so once you get it developed, the water coming out of the ground is essentially free of solids. But if you've got an open excavation, like the one we had along the Platte River, full of silt and clays, it's a whole different treatment train to deal with those suspended solids. And then the third question is, do you know going in, is there contamination on the site, on your site or surrounding sites? And typically, when developers are doing these types of jobs, they'll already have a phase 1 or a phase 2 site assessment done on the property. So they know going in, like Jeff knew, that, hey, there was a possibility of some contaminants in the groundwater. If you've got that up front, you can plan ahead and say, hey, when we do start dewatering, we'll be prepared for what's on our site, or be prepared for what you may bring over. You may pull something over from the adjacent property. And then the next, let's see, oh, I'm sorry, yeah. And then what are you doing with the discharge? Are you going to sanitary or stormwater? And if you are, have you applied for your discharge permit yet? And then one thing I mentioned earlier is, does the discharge permit jive with what your dewatering contractor thinks he needs to pull out of that hole to keep it dry. So I mean, will the sanitary sewer or whatever or the storm sewer, will it take the volume that you're gonna throw at it? And then is the system going to be continuous or batch treated? You may get into sites where it's very clay rich, very silt rich, and you may just get maybe a couple thousand gallons of water in the hole during the day. You could pump that off into a weir tank or frac tank and just hold it for days, and then put a very temporary treatment system on it to batch treat it whenever you need it. And then other considerations as far as operation and maintenance. Do you want a turnkey or do you want to operate yourself? And then footprint. Some of these inner city projects, you've got a city block to work with, and there's not a lot of room for treatment equipment. So things to think about before you open or at least open the pit. And then power supply, freeze protection during the wintertime. We've got enclosed trailers, but is it needed? Analytical testing, like Jeff mentioned earlier, have you got someone lined up that's going to do the water testing, and who's going to do the reporting? And then safety concerns on the site as well. So that pretty much wraps it up. I mean, for recap, we kind of went over the capabilities of both the companies here, and when water treatment's needed on dewatering sites. Went through the permitting requirements and gave you some examples of the different types of treatment processes and equipment we have. And you got Jeff's perspective on his site down there in Muskegon. Went through some case studies and the questions you should ask. So I guess at this point, we'll open it up for questions.
All right, thanks you guys. This is Mike again, coming in from the back behind the curtain. Some questions did come in. Jeff, I'm going to start with you. What was the most difficult aspect of the project that you just went over?
I think the headwind that we had going into it was we weren't really prepared for PFAS, right? And when it hit us, we were very concerned about our budget, right? And so being able to find the right partners, understanding that we didn't have the budget in place at the time. I worked with Dan Mitchell from your team actually, and on that initial piece. And being able to walk through that, go through what's the process here, what can we find from a grant process. That was one of the challenging pieces that I found. I think I didn't sleep for those first 2 or 3 weeks because we were filling out probably 500 pages worth of paperwork at the time. But ultimately, having people that walked through it made that a lot less of a challenge. But at least for me, from a stressful standpoint, it was trying to understand the implications of budget for the entire project. So
Cool. Dave, I think this is yours. If there are people, if you have an operation that's going 24/7, does Evoqua have someone there the whole time? Is it your guys or our guys?
Yeah, in whether the system is automated or not, we need a system operator there watching the system at all times, and we can work with the contractor on managing, who's there. But typically, you don't want to leave a system operating unattended. So yeah, we usually, we like to have our system operators there at all times the system's running.
Cool. Jeff, how difficult is the EPA or the Eagle in Michigan, the grant funding process? What's that like?
sure. Again, I don't think it was challenging for sure. We had a lot of help, this having county and city ties to it being a very important project for the municipal. I was able to lean on a lot of people that had grant experience, right? Some of them do it for a living, just writing grants and trying to find appropriate funding to help their community. But it was challenging. I think we went through probably 5 or 6 different iterations. Again, that piece working with the EPA was there was a long process there. Part of that was we had to find the entire budget. We had to go through every subcontractor, see what their costs were on a per day basis. So it was pulling in, several 15 different people from different companies to figure out what that pricing was on both the best case and worst case scenarios, because we just didn't know what we were facing, which is a little bit different than what I'm used to in the construction world. Usually I can define something, and this was, you know, dealing with it somewhat undefinable for us. And going through the entire grant process, we were able to work through those steps. Definitely had good partners that helped that out.
Awesome. I'm going to give you one more, Jeff, and I think we had a couple
Sure.
coming in for Dave. I'm guessing that you would recommend an owner's rep, but what circumstance would you recommend an owner's rep? You know, and why would that be? Like, what is
Yeah.
the feature
Obviously,
there?
I'm a proponent of good representation, but it's not required on every project. Typically, I find it's good when you need to align a lot of pieces, right? You have complexities on a project. You have maybe separate multiple owners, right, that are working on it. In this specific project, we had 9 stakeholders, right? So 9 people from an ownership team that needed to, you know, efficiently and effectively give communication. So being able to come alongside them and say, I can give that communication back to people was appropriate. So I think when you have a project that's complex, when you don't want to take your business or what you're doing on the day to day and kind of set that to the side so you can run a project, yeah, it's helpful to have somebody who's been through it before. So that's my plug.
Yeah, no, that's awesome. Dave, there are a couple of more technical questions, and I know we mentioned earlier that this presentation has a large appendix. So I'll ask you this, what exactly did you mean by polymer addition, and when do you need it?
Yeah, we use polymer addition, and it's just it's an addition of a coagulant and a flocculant to the water. It's environmentally safe material, but it helps drop out those suspended solids, those little clay and silt particles in there. What can I get to the? Yeah, I can get to the appendix. Can I?
Mm-hmm.
Yeah, hold on. I can. We've got. Here we go. Here we go. All right. So what you're essentially doing is you're just adding this polymer to the water stream, putting it through a static mixer, and this is the little stuff here on the left is the coagulant or the flocculant that we're adding to the water stream. And when you mix it with the water with the little sand particles, each is got a, you know, what the polymer's got a little negative charge, and the particles in the water have a positive charge. So they match up and they start building a flock, and the flock gets bigger and bigger. And within 2 to 5 minutes, you've settled out those solids. And then you can push this clear water through your treatment system, and you catch this flock, the sand, and well, I shouldn't say sand, but the silt and clay and stuff that's settled out. You capture that in a weir tank or a geo bag, a big pillow, clarifier, something like that. So just, yeah, it's an easy and quick way to drop out solids quickly, so you're not overwhelming the rest of your system, your sand pots and bag filters, so they're not constantly backwashing, or you're not changing bag socks or filter socks like every 20 minutes. So the whole idea behind polymer addition.
Yeah, cool. Thank you. Then it looks like possibly the last question has come in. You mentioned sand pods and bag filters. Are there examples of that?
Yep. And then see, this is how you capture that flock in a pillow, these geo bags, or particularly, this is or a weir tank, a 3-chamber weir tank. But after you get those solids settled out, you can push it through sand pots. It looks like a typical pool filters. That's pretty much what it is. It's a pod with sand in it and gravel on the bottom. So you've got a little space on the top, sand, gravel on the bottom, and on the very bottom of the pod are these screens, stainless steel screens. So you pump, the water still has a bit of, I would say it's dirty. It looks, it's not clear yet, but once you push it through the sand and the gravel, it comes out pretty clean on the back side. And then from the sand pods, this is kind of like your pre-filter. The sand pods, then you can move it to bag filters, and the bag filters look like this, like what we had at Jeff's site. These are stainless steel housings, And inside each one of these little housings is a stainless steel screen. It's really a colander. And in the colander, you put this filter sock, and you can get these socks in all different micron sizes, depending on, you know, what you're dealing with. And then you put the cap on. So the water comes in through the top of the sock, pushes out through the side of that screen or that colander, and there's a space around the screen, and that's where the discharge goes. So, and you really need to do this. You know, you put a sand pot or a bag filter on prior to treating with media, like, you know, your carbon or, you know, AA or ion exchange resins, that sort of thing, because you just don't want those fines blinding off your media beds. So that's what those are.
Cool. Well, thank you. That was the last of the technical questions, but Jeff, I did have one for you.
Yeah.
This is a personal thing I'd like to know. So if you don't have an owner's rep on a complex job like the one from Muskegon, what's it going to be like for someone who has never been through that process before, or doesn't know who the next person to call is in their local government, or they run into something? What's it going to be like for them if they don't have someone on site who knows what they're doing?
Yeah, you know, that's the biggest challenge. A lot of people get bogged down with not knowing who to call, where to take your next steps. So, you know, in this situation, I'm a connector. That's a lot of what I do. And so by starting where I did, I made the phone calls. I called my local Eagle rep, who I know, right, personally, and then I also spoke with my dewatering contractor. I said, where do we go from here? And so I was able to, you know, you got to just track it down, but finding the right people who've been through it before, right? It's like anything. Find support networks, find professionals that have been through it, and make sure you can align that team. I'm really good at team building. Like I said before, I'm not a PFAS expert. I still probably can't tell you how to pronounce polyfluoral, right? But that's the reality of it, is find good team members. I found that with you guys in Evoqua. I mean, that's why I'm here to talk and share our project, because it went so smooth, right? It was a huge undertaking. It had, you know, high risk from our perspective, you know, because it wasn't just the water treatment. It was, if we couldn't do this right, we didn't want to be in a position where we had to go back to, you know, the city and county and say, we just can't do this project on your budget. So finding the right partners was critical. You know, you guys had a small big piece in actually getting something that was a 13-year process of designing this building pulled together. So it was a big deal. Yeah, hopefully that answers your question, but one
Yeah,
step
it
at a
sure did.
time.
Yeah, no, that was awesome. That's it. Gentlemen, thank you very much. That was a great presentation. I really appreciate it. And everyone who was on the call, we really appreciate your time today. Thank you so much for coming. And we will send out a link to the video when it is posted. And we will also send a link to this presentation with the appendix as soon as it is ready for prime time. So thank you very much for being here.
Yeah,
Thanks,
appreciate it,
everybody.
Mike. Thank you.